Welcome to this video lecture on equivalent circuit of three-phase induction motor. We all know any complex circuit can be represented as a equivalent circuit. It could be a circuit or it could be a network also. We can draw a simple equivalent representation. We'll just see an example here. Right here we find a motor circuit. So the armature of the motor is represented here, and voltage is applied to the armature. And in the right hand side, you see the equivalent representation of the armature. In armature only, back EMF is developed, so that back EMF can be represented as a voltage source. Armature has got a rotor coil, resistance coil, so resistance can be represented here. And you have brushes in the like armature. Automatically, whatever voltage drop that happens in the brush can be represented as a voltage source along with the input voltage. Similarly, it can be extended to a generator also. The same concept we can apply it to a three-phase induction motor also. Right? Whatever representation that shown here, it is per phase representation. And like we all know, in the stator, there's got a three-phase winding. So the winding can be represented with a resistance R1 and X1. With the help of that winding only, a magnetic field is established. So magnetic field can be represented as R0 and X0. So these components, they deal with the stator circuit. When it comes to the rotor, it is the rotating part of the machine. And whatever output is going to be a mechanical like output. So we are going to represent the electrical parameters, that is R2 and X2. And the value of X2, it is dependent on the value of slip. So when you draw the equivalent circuit, we cannot have a variable reactance. It is impossible to realize the variable reactance in practical. So we can have it as standstill reactance with variable resistance. So that is why the rotor in rotor circuit, it is represented with R2 by S. So this R2 by S, again we can split it as R2 and like a factor of R3. This it is written as R2 and R2 into 1 minus S divided by S. And we all know in transformer, a secondary parameter can be shifted to primary side, and primary parameters can be shifted to secondary side. The same way, right? The rotor components can be referred to the stator side. So when the rotor components are referred to the stator side, it is going to be represented as R2 dash, X2 dash, and like RL, it is going to be RL. And when you do this transformation, automatically we have to consider the turns ratio of the machine. So the transformation ratio, right, has to be considered. Normally for induction motor, instead of giving it as rotor by stator, it would have been mentioned that stator by rotor only. So we have to do the like necessary like changes there. So it is going to be that transformation ratio has to be considered. So R2 dash is equal to R2 by K square. And when it comes to current, it is going to be current into K square. For resistance, it is divided by K square. For current, it is into K square. So when you shift your rotor parameters to the stator side, further the circuit can be simplified because you have two resistance in the circuit in series, two reactance in series. So you can write as a one value of resistance and one value of reactance. So it is normally referred as R01, X01. So whatever transformation that you do here can be done by shifting stator parameters to rotor side also. That is also possible. Again, right, you will have changes in your when calculating your R1 dash value and I1 dash value. Right, sufficient correction has to be considered here. And whatever power relationship that you have, right, the standard power relationship that you have, right, it is going to be the same, right, provided you shift your theta parameters to the rotor side or rotor parameters to the theta side. Hope you have understood this equivalent circuit concept, and you'll be able to take up this assignment also, this assessment also. Very important when you shift your theta resistance to the rotor side. What has to be considered? Should it be resistance divided by k square or into k square? You have to tell me the answer. And when you draw the equivalent circuit, will it be R02, X02, or will it be some other parameter? All these things you have to consider while answering this assessment. Thank you.